All right, in 11.6, we're going to be talking about complex fractions. A complex fraction is a fraction that has fractions in it, and it looks very complicated. We are never to leave a fraction with a fraction as a part of the numerator or denominator. That means you also can't leave decimals either inside of a fraction. You need to simplify them. So a couple different methods to simplify a complex fraction. This first one follows PEMDAS, and so recall that whenever you have a fraction, the fraction bar is considered a grouping symbol, and so it's grouping the numerator, grouping the denominator. So I'm going to take the numerator, and then I'm going to divide it by the denominator. So PEMDAS, I'm going to complete the parentheses, get a common denominator, so that's going to be 15ths, and that's 3, that's 5, that's 10 15ths minus 2 15ths. So that's going to end up subtracting to be 8 15ths. Divided by the second one, it's fifths, so it's 1/5 plus 10 fifths, common denominator, and that's going to end up being 11 fifths. So I'm going to take my first fraction, 8 15ths, keep it the same, change to multiply, and flip the second one to 5 11ths. My 5 and 15 will reduce to 1 and a 3, and then I'm going to multiply across the top and get 8, and across the bottom and get 33. So my complicated, complex fraction turned into the very simple 8/33. So the second method, we can be clever about it and multiply by a clever 1. To do this, you're going to have to find the LCD for all the little fractions inside my complex fraction, both numerator and denominator combined. So, in this last one, we did it separately. We had a 15 for the numerator and a 5 for the denominator. But when we use this clever method, you have to have the same denominator for both numerator and denominator combined. Then we're going to multiply the big fraction by LCD over LCD. So there's my clever 1. We'll distribute the LCD through the numerator, distribute the LCD through the denominator, and then we'll factor and reduce the result. All right, so this is my third time through. You see over here how I've changed that now. That was a 4. I'm going to change it to be 2 15ths. I kept getting different answers, and it took me 3 times to realize that I'd copied this down wrong. So change that to a 2. All right, so I'm going to look at all 3 of my fractions in my complex fraction. So I have a denominator of 3, a denominator of 15, and a denominator of 5. So for those 3 denominators, a common denominator would be 15. So then I'm going to take and I'm going to multiply the numerator by 15 and the denominator by 15. Because I'm multiplying fractions, you may want to think about it as being 15 over 1 for both of those. But you can see my clever 1, 15 over 15 is 1, and it's not going to change the value of my fraction. So distribute. So I get 15 over 1 times 2/3 minus 15 over 1 times 2 15ths. So see me distributing on that. And then when I multiply these, the 3 and the 15 cancel, gives me a 5. So I get 10 over 1, which is 10. Then on my next one, my 15s cancel, and that gives me, 15s cancel, that gives me 2. So minus 2. All over my denominator, distribute 15 over 1 times 1/5, and that's going to give me 3 plus 15 over 1 times 2 over 1, which is 30 over 1, which is 30. So plus 30. So 10 minus 2 is 8. 3 plus 30 is 33. And voila, there is my new simplified fraction. Again, 8 over 33. All right, so I'm going to choose to use the second method because I think in the long run it's just so much quicker that we might as well just learn it now and do it. If you choose to do the other method, fine with me. I have a hard time going through it though. All right, so let's look at some. We're going to completely simplify these. So since I'm choosing the second method, I want to know what the LCD is of all the little fractions. So I've got a 2, a 6, and a 3. So LCD then would be a 6. So I'm going to multiply this by 6 over 6. And when I do, you get 6 times 1/2, so that's 6 again. Remember, it's 6 over 1. So 6 times 1/2, that's 6/2, which is 3. Then 6 times a negative 1/6, so that's 6 over 6, which is 1. Then we're distributing here. 6 times 1 is 6, minus 6 times 1/3, that's 6/3, which is 2. And that's going to be 2 over 4, which reduces to 1/2. Here's my next one. Again, LCD is, again, 6. So I'm going to multiply this by a 6 over 6. 6 times 1/2 is 6/2, so that's 3. 6 times 1/3 is 6/3, so that's 2. 6 times 1 is 6. 6 times 1/6 is 6/6, which is 1. So I get 5/7 for that answer. And 3, LCD for 4 or 5 and a 5 would be 20. So I'm going to multiply this by 20 over 1. I'm going to multiply this by 20 over 20. So again, it's over 1. And when I multiply it times my numerator, I'm going to get 24ths, which is 5, minus 25ths, which is 4, divided by, multiply it times my denominator distribute, so I get 20, minus, this next one I'm coming up with 20 over 1 times 4/5. So, so I got 5 minus 4 up here, which is 1, divided by 20 minus, here you can see the 5 will go into 24 times. So 4 times 4 is 16, so minus 16. So I get 1/4 for that answer. All right, so next, we'll do it with some variables. So we've already been working with finding the LCD. So I need to figure out what the LCD is for a y squared, and a y. So y, remember we want to take the larger exponent, so we're going to multiply this by y squared over y squared. Remember, we want the clever 1. So whatever I do to the numerator, I have to do the same thing to the denominator. So I've got to make sure that that's going to happen. So so that I'm multiplying by 1. So I'll show this distributing. So this is like y squared over 1. I'm going to distribute it through, so times 2 over y minus y squared over 1 times 7 over y squared. So there's my numerator there. So my y squared going to cancel. It's going to leave me with 1 y in the numerator, and that's going to be equal to then 1 y there, 2 y. It'll be 2 y over 1. So that's 2 y. If your denominators don't go away, if you end up with something left in the denominator when you distribute like that, it means you chose the wrong LCD. Here, this one, both of them are going to cancel, and that's going to leave me with a minus 7. The denominator is going to be y squared over 1 times 3 over 1 plus y squared over 1 times 1 over y. So nothing cancels in the first one, so 3y squared. And then the second one, I have y squared, y is going to leave me with a y right there. So I get y times 1, which is y, so that's going to be plus y. You might take a minute and look at that and think about whether it will reduce or not. This actually doesn't. So this is the answer. You could also leave it with that denominator factor showing y times 3y plus 1. And again, you can see that it does not reduce. So either one of those would be acceptable. And then my last, I think this is my last one, maybe not. Here I've got I'm going to look at my different denominators here. So I've got the A, a B, and an A. So my LCD has got to have both an A and B in it, no exponents. So when I distribute and multiply by that clever one, it's going to be AB over AB. So numerator, remember, so you see how it is. So this is really over 1 and over 1. So distribute. So I end up with AB over 1 times 1 over A plus AB over 1 times 1 over B. So I'm going to cancel my A's, and that leaves me with a B, and then plus, cancel my B's, and that leaves me with an A. Then denominator, I have AB over 1 times A over B minus AB over 1 times B over A. Let's say cancel my B's, and that leaves me with A squared. So that leaves me with A squared here. And then cancel my A's, so minus B squared. Still I have B plus A divided by A minus B, A plus B. And A plus B and B plus A are exactly the same thing. So my answer comes out to be 1 over A minus B, final answer on that one. Oh. So here, one last one that I will do, and that is 1 over x minus 1 over y divided by x minus y. When you look at this one, notice that the only little fractions in that complex fraction are just up there. My denominator does not have any fractions in it. Doesn't matter. I still have to multiply by a clever one. So I'm going to multiply by xy in the numerator and xy in the denominator. And again, it's over 1. And this one doesn't really need to be put over 1, but it's over 1. So it's going to be equal to, when I multiply the numerator, I get xy over 1 times 1 over x minus xy over 1 times 1 over y. So cancel, cancel, cancel. That leaves me with a y minus, cancel my y's, x divided by. In the denominator, you could distribute it, but because you're going to want to factor in the long run, you might just leave it in a factored form, xy times x minus y, and just leave it written like that because it's factored. You could distribute it and then undistribute it, but you come back to the same thing. So over here, I'm going to have xy times x minus y. These are almost the same thing. These are almost the same thing, but they're negative. So those cancel to be -1. So I get -1 over xy for my answer. If you'd like to try some of these tonight, you can try these next ones, and I'll flip it back on with the answers included on there. So give this a try, and we'll work on it tomorrow more in class. Okay, so here are these answers. Hopefully you've tried them, but you can see some more examples here on this. So the first one simplifies to be m plus 1. The second one simplifies to be 6k minus 1 over k minus 12. And the last one, multiplying through by a, gives me 2a plus 3 over a times a plus 2. See you tomorrow.